Hey all, welcome back to my channel. So in today's video we are going to discuss about all topics of Verilog in one go. I have already previously made this video like dividing it into two parts in Verilog in one shot in two parts, but many of you have requested me to make it short and to cover all the topics in one go itself. So that is why I have prepared this video for you where I have covered the entire topics of Verilogs in one shot. So these are the topics that I have covered in this particular video. They are Verilog language basics like what are HDLs and Verilog constructs like we have covered about data types, vectors, operators, all the things. And also we have covered about tasks and functions here and what are modules and what are ports. And again we have discussed about assignments like what is continuous assignment, what is procedural assignment, and also we have discussed about modeling styles like four different levels of modeling and compiler directives and Verilog timing regions also. Okay, so these are the things that I have covered today in this particular topic, and also we have discussed about system task usages also, right? So these are the things that we are going to cover today. If you are someone who are having doubt on this particular topic, you can go through this video. HDL is nothing but hardware description language. So what does this mean? So hardware description language is a programming language which will describe the structure behavior of the circuit. Okay, so simply putting in simple words, HDL is nothing but text format of the design that you are designing physically. Okay, for example, if you are designing an adder, okay, before designing it physically, you will be writing it in a text format, in the coded format, which is by using the HDL. Okay, simply. Okay, that is the simple meaning like what is HDL. Okay, but even though in the previous I have told you that this is a programming language, yes, HDL is a programming language, but not a software programming language. Why? Because if we go into software programming language, any language will be used in order to create a software. But in this hardware description language, we are actually describing something. That is why that is called as HDL. What are we describing? We are describing the behavior of the circuit. Okay, so based on the behavior of the circuit, based on how we are describing, in that way only the physical circuit is being created by the PD, like backend department, right? So this is about HDLs. So it is having so many advantages, like HDLs are having so many advantages like reusability, flexibility, lower costs, and also for better simulation. Like basically, by using HDLs, the simulation is much more improved. Why? Because we can easily find the bugs, and then the bugs can be modified by the design engineers before they can actually go into the physical formation. Like before fabricating the physical chip, they can be easily modified by using this HDLs. Okay, and also you are having many reusability and flexibility purposes. Okay, now coming to Verilog HDL. So what is Verilog HDL? So actually this HDL is again, when we see in the real-time industries, most frequently two types of HDLs are used. One is Verilog HDL and then VHDL. But mostly almost 70 to 80% industries will be opting this Verilog HDL. So why? What is the reason behind opting the Verilog HDL rather than VHDL? Why is it? Because Verilog is very easy to learn and it is easy to understand. And also the syntaxes are familiar with many other languages like C, C++. Okay, the syntaxes that you are using in Verilog are very similar to C language. And even though you don't know C also, you can easily understand it. Also, it is a case sensitive language, right? So basically most of them opt for Verilog HDL rather than VHDL. So in this video we are going to talk everything about Verilog HDL. So as I already told you, Verilog is very easy to learn and it is similar to C language, right? And in Verilog, when you are writing a code, you can opt for four different abstraction levels. Okay, that means you can have four different coding styles while you are writing a code. Like you can have behavioral coding style, data flow coding style, gate level coding style, or switch level coding style, right? When you are writing a program, you can write in any of these four abstraction levels, right? So this is about Verilog HDL. So now we are going into the language, like what does this actual Verilog HDL consists of. So as you already know that Verilog HDL is a programming language, right? So any program is built with some syntaxes and some properties, is it or not? So basically in Verilog, when you are building a code, okay, everything you will be built within the module. So we can call these modules as basic building blocks. Why? Because whatever code you are writing within the Verilog, you will be writing within this module and end module. Like if you see here, within the module and end module, you will be writing the implementation is nothing but the entire code will come under this particular thing. So it is module describes boundaries, like within the boundaries you will be writing and module followed by module name along with ports list. Okay, so this is how you will be writing your code, like module and module name followed by ports list, right? So within the implementation you can write any, like you can use behavioral modeling as we discussed before, or we can have data flow modeling or switch level modeling, anything you can implement, right? So let me show you a small example here, right? Within the module and end module, for example, if you are writing a full adder code, okay, module, any name, this can be of any individual name. Here I am just mentioning it as full adder else. So within this, okay, within the parenthesis itself, I am mentioning the ports like ABC, and like if you see here for full adder, you will be having three inputs and two outputs, sum and carry, is it or not? So the three inputs and two outputs are also mentioned within the module and end module, and this is the logic which is implementation and end module, right? So in this way, any code you are going to write, you will be writing within the module and end module. Now coming to the important topic, which is module instantiation. So what is this module instantiation? So put it in simple words to make you understand simply, it is just like a copy. Okay, if you see the word, if you see the dictionary word for instances, what is the meaning of instances? Instances means copies. So what are the copies? Copy is nothing but, here for example, okay, let me explain it with an example so that it will be easily understood for you. For example, I am writing a half adder code here. If you see, this is my half adder code. Okay, and this is my half adder. Now, I want to write a full adder code. Okay, but for this, what I am doing, I want to design a full adder by using two half adders. So, if you don't use any instantiation here, what you will do actually, you will be writing codes for two half adders separately, and then you will be creating one module for this, again one module for this, again for these two, again you will be adding this particular carry adder or get, and again for this you will be adding the sum and cout. So in this way you need to write everything. Like if you are going to write, for example, if you see the code here, it is consists of some 10 to 15 lines of code for half adder. Now if you are writing the full adder by using the same two half adders, you need some 30 to 40 lines of code in order to write, is it or not? So while simulating your code, what happens, the lengthier your code is, the simulation, the more simulation time it takes. So that is why, in order to reduce the time, memory and everything, so what have we done here is, in Verilog you are having a concept called instantiation. This is the reusability that is we are talking about in the before topics, like advantages. In case of advantages of HDL, the first thing we have discussed about is reusability. So what does the reusability mean? Based on these concepts, okay, not only instantiation, we are having various other topics which will help in reusability purposes. So here what actually we are doing, we will be writing a half adder code here. Okay, one time we will be writing the half adder code. Okay, if you see here, this is my half adder code with the name half adder. Okay, so now by taking that half adder name, you are creating two instances. So this is my half adder. Okay, and now I am creating two instances for this, like HA0, HA1. So by creating two instances, nothing but two instantiations, you are creating two copies, you are creating, and you are taking again the individual ports. Like if you see here, it is having A, B, S, C as ports. Like here, C in and S sum and C1 are its individual. So if you see here, when you are creating instantiations, every instance will be having its individual port connections. Clear? So this is how the instantiation helps in reusability purposes. Like you are creating a copy for the actual parent module. Yeah, what is the instantiation means? You are creating a copy for the parent module, and by taking that copy, you will be connecting the ports individually. Right? So this is about the module instantiation. Hope it is clear for you. If you see here, these are the instantiations, module instantiations. Okay, so module instantiation is very important. Why is because as I told you in verification, in the starting, like in the design flow, VLSI design flow, we have discussed that in verification the verification engineer will be sending some stimulus to the RTL. So how you will be sending the stimulus from test bench to RTL? You need a connection. So how you will be connecting? By instantiating that design to the test bench, you will be connecting this ports and that ports. Okay, you will be discussing it in this video itself. I'm just giving you some hint, like what is the instantiation and where is it actually used. Right, so this is about module instantiation. So before going into, like, every language will consist of some tokens, lexical tokens, like basically some syntaxes we need to know before writing a code. So these are some of the syntaxes that you should know before going into the Verilog HTL, in order to avoid any semantic errors. Because during simulation, because every code is built with some syntaxes, you should know that syntaxes in order to write your code correctly and in order to simulate it perfectly. So that is why, in order to avoid any syntax or semantic errors, you should know about these particular topics. So I don't explain in brief about all these things. Okay, I'll just give you small explanations on these things. Like white space, if you see, you should know at which point of time you should give the space and which point of time you shouldn't give the space. Okay, so that is important. Like if you see here, end module, if you see this is the keyword. Okay, between the end and module you shouldn't give white space. So that is the syntax. You should know where to give and where not to give. Right, so this is about white space. And then coming to comments. Okay, comments are actually, if you don't want any particular logic to be activated at that particular point of time, you can just keep it in comments. So basically, this is not the only purpose for comments. Basically, if you see the code, whenever you want to explain your logic to someone, as soon as they see the particular code, if you want them to understand your code, mostly everyone prefer writing the logic, like why they have written this particular logic in the comments. Okay, so comments are useful for that also. Basically, in Verilog, just like in C language only, here Verilog syntax is also same for comments, right? And then coming to operators. Operators are very important. Like based on all these operators only, you will be writing your logic. Okay, so without these operators, you can't write the logic in the data flow modeling, right? That is why, so operators are very important. And in Verilog, you are having various categories in operators. Like, see, if you see arithmetic, relational, equality, logical, bitwise, reduction, shift, conditional, concatenation. So based on using all these operators only, you will be writing the codes. So these are the symbols for operators. You can just pause it and just check out these operators. Okay, if you're confused about the operators, you can just pause this video and check this particular video. And if you want the clear explanation of this, as I already told you, I link that playlist of Verilog HDL tutorial in the description box. You can go there and check every video you want, right? So now coming to some lexical tokens. One of the lexical tokens is constants. So constants is nothing but when you are assigning some value to a variable. For example, a equal to 5. Okay, 5 is assigned to some variable a. So in Verilog, you can't just assign it simply a equal to 5. Why? Because it needs some syntax. So what is the syntax? In order to assign some constant to a variable, you should follow this syntax. Like first you should give the size. Okay, so what is the size of the bit? Like if you see here, this is the 4-bit size. Tick. And next is radix. Radix means whether it is of binary or decimal or octal or hexadecimal. That is the radix, which format. And then the value. Value is nothing but which value you want to assign. So in this way, you will be assigning the values. You needn't just give it like this. Even though if you are giving it like this, you will be having some things. If you see here, if you are giving it just like 14, now what is it? This is the unsized decimal. So what happens if you are just giving it, even though you are creating it as a 14 but extended to 32 bits, but even though you are not mentioned, since you didn't mention any size, so the automatic 32 memory locations are created. Okay, so because by default the unsized decimal's default value is 32 bits, so if you are not mentioning any size, it will be taking a 32-bit memory locations. Because of this, there will be wastage of memory. Okay, so that is why if you are a beginner and if you are writing a code, okay, it is advisable to write anything by mentioning the size and radix also. Okay, so this is the sized constants. If you see here, these three are sized constants. This is unsized constant. So unsized constant is obviously 32-bit by default. Okay, and if you want to assign any x and z values like unknown values, high impedance values, because these are for x and z values, you will be mentioning it like this. Okay, for real numbers, and this is for negative numbers. Like so, these are some basic constants that you will be seeing in the Verilog language. Then coming to identifiers. So identifiers are nothing but they are just the names. Okay, for example, in the previous example we have seen that module we have given half adder. So that half adder is a name. You can give any name you want. Okay, identifier is nothing but just a name, and you can give any name, but you should follow certain rules while you are giving the identifiers. So why are these identifiers needed? Like for example, if you are writing some function and if you don't name it, how can you call it at some point of your program? Similarly, you are creating an instantiation, module instantiation without naming your module. How can you instantiate it? Is it or not? So that is why identifiers are important. And also it has certain rules, like you can use any of these alphabets from uppercase A to Z, smaller case A to Z, and 0 to 9. And for special characters, only these two are allowed, like underscore and dollar. The remaining all are not allowed. And also, the identifier should not start with these two things. Okay, and it should not contain only numbers, but it should not contain any white spaces, that means any gaps in between the names. Okay, keywords cannot be used as identifiers. You can use any underscores. Okay, like if you see here, these are some examples. Why are these four invalid identifiers? If you see, because it shouldn't start with number. It can contain numbers, but it shouldn't start with number. It shouldn't contain only numbers. It shouldn't contain the special character, and then here it is space. Okay, so this is how, if you want to give a name, you should give it based on all these rules and regulations. And if you don't want to follow all these rules and regulations, there is a way, which is an escaped identifier. So escaped identifier means if you don't want to follow any of these rules but you want to make this as a valid identifier, you should just give a backslash before. When you are mentioning a backslash before any identifier, then that is considered as escaped identifier, and because of this, the simulator doesn't throw you any error. Clear? So that is about identifiers. Now coming to Verilog keywords. So just like in other languages also, in Verilog also you are having some inbuilt keywords within this particular language. Okay, so these are some of the Verilog keywords, not all the Verilog keywords, but in the Verilog these are some of the keywords that you will most frequently use. Okay, so if you see, all the keywords are in lower sensitive, they are case sensitive and they are of lower case. Okay, so these are already inbuilt in the Verilog. You can just use them wherever you want, right? So this is about the lexical tokens that we are discussing about. And now coming to the next important topic, which is data types in Verilog. right? In data types in Verilog is very important, and in among the data types the most frequently used are nets and registers. So again, registers are subcategorized into two types, like various types like reg, integers, real time. Similarly, nets are also subcategorized. Now let us see what are these data types. Okay, so first coming to net. Net data type is nothing but, for example, as I already told you, when you are designing a circuit, or when you are designing something, and when you want to connect one component to another component physically, what you will do, you will be connecting it with the help of wire. Is it or not? Similarly, when you want to connect one element to other element, or one module to other module, okay, in particular code, what you will be using, you will also be using wire. Okay, but that wire is by using a wire keyword instead of physically creating a wire. So what does this wire do? It will send the data from one component to other component. So simply, just like a physical wire, what it does, it will be sending the information from one point to another, not information or anything, it will just sending anything from one point to another. Similarly, in code also, in Verilog language also, wire keyword, what it will be doing, it will be sending the data from one component to other component. So simply we can take that wire is the something, is the data type which is used to drive the value. So the work of the wire in Verilog is to drive the values. That's it. Okay. So by default, the value of wire is z. Okay, if you don't mention, like if you don't give any value to this particular wire, it is z. Actually, nets are declared with keyword wire. Okay, most in codes you will be using the keyword wire. Again, this wire is subcategorized into various types like WN, WO, try and supply 0, supply 1. Okay. So this is about wire. Like net data type. In net data type, it is mostly we'll be using a keyword called wire. Wire is used to drive the values. It is just used to drive the values. Like if you see this particular code, okay, here A, B, C are inputs, Y is output. So all the input and output ports are declared within the particular module. But if you see here the intermediate connections, if you see here, you don't need to mention this intermediate connections within the ports list. Okay, you can just use wire or rich data type in order to give all these intermediate connections a declaration. So if you see here, mostly all the intermediate connections will be given as wire. Okay, so wire T1. Clear? So if you see here, if you see this particular full adder circuits, here A, B, C in are inputs and sum and C out are outputs. So input and outputs are declared within the module. Now if you see here, you are having some intermediate connections here. So all these intermediate connections are given for wire. Right? Got it? So this is about wire. So just if you see here, what is this doing? C is just used to drive the value from this gate to this gate. Okay, so that is what it is doing. Similarly, C1 is used in order to drive the value from this point to this point. Okay, so you can just remember it like that. Wire is just used to drive the values. Okay, now coming to register data type. So it is entire opposite to wire. Like what is wire doing? It is driving the value, that it is sending the value. So okay, for sending the value we are having a component. Then for storing something, you need to have another data type, right? That is register data type. Okay, so reg will be holding the value instead of driving the value. It will be holding the value, like it will be holding until it is replaced by other value. Clear? So this is about register data type, and by default it is of value x. Okay, and it is declared by the keyword reg. Okay, right? For net you will be using the wire keyword, and for register data type you will be using the reg data type, reg keyword. Okay, clear? So in order to store the value, you will be using this register data type. It will be retaining the value until another value is placed onto them, right? So this is about register data. Again, register data type is again categorized into range, integer, real time, etc. Okay, now if you see here, the same program, but here in the previous I wanted to drive the value, but now here I want t1 to be used as storage value, that I want t1 to store some values, hold the values. That is why I'm mentioning it as rich. So if you are using it as t1 as rich, then the t1 will be holding the value. If you are using it as wire, then it will be driving the value. Clear? Yes. Now coming to integer data type, like integer, just like rich and net data types. Okay, integer is also a data type which is used in order to declare some numbers. Okay, when you want to declare it in a number format, then you will be using the integer data type, and by default it is of 32-bit register. Okay, so this is declared by keyword integer. Similarly, real also for storing the real values, like floating values. In order to assign floating values, you will be using the real data type. Now coming to time. So what is this time? Basically, when you are simulating some code or when you are doing some code, okay, you need to know at some particular point of time if you want to know the simulation time. So what is the simulation time? It is nothing but an amount of time which is spent on simulating the module. Okay, like how much time it is, your particular, if you are having some 10 lines of code, okay, at fifth line of your code, how much is, what is the simulation time, like at what point of time this fifth line of code is being executed, being simulated, sorry. So all this, in order to know, you will be using this time data type. Okay, by using the $time keyword system function, okay, you will be getting the value of the simulation time. You will be knowing the current simulation time by using the $time system function. Clear? So this is about Verilog data types. Now, if you see here in the previous, we have talked about, while we are talking about region net, okay, all the region net data types are scalar data types. That means they are single bit data types. Now, if you see here for integer, it is a 32-bit by default, but for region wire by default they are of single bits. Okay, so single bit is nothing but scalar bit. Now if you want to increase the width of the bits, okay, how can you do? By using the vector representation. Okay, so scalar means single bit, and if you want to increase the magnitude of, if you want to increase the width of that particular variable, then you can be using this vector representation. Okay, how are we going to represent vector? If you see here, wire x. Okay, so if you didn't mention any width before, so that is why it is a scalar. So by default it is scalar, right? So x, y, z all are scalar values. Now if you want to increase the width, how you will be doing? You will be mentioning the width, like 5 down to 0. So this is of 6 bit. Similarly 7 down to 0, 8 bit, 11 down to 0, which is 12 bit. So in this way, in order to increase the width of that particular data types, you will be using this particular scalar and vector representations. Right, now coming to Verilog arrays. So if you see, for example, like rich a, okay, this is my particular a. Now if I want to take, okay, some register data type, I want to take some 10 variables like a1, a2, a3, similarly up to a10. If I want to take 10 variables which are of same data type, is it possible? Yes, it is possible through Verilog arrays. So Verilog arrays means ordered list of variables. So ordered list of variables which are having the same data type. Okay, if you want some group of variables which should contain the same data type, and instead of mentioning every variable individually, you can just by use define it by using the Verilog arrays concept. So if you see here, this is how you will be representing your array, like register a 3 down to 0. That means here if you see here a, it is similar to a1, a2, a3, a4. Instead of creating a1, a2, a3, a4 four elements individually, you have just taken one variable name which is a, and I am taking the width, I am increasing the width of this particular element. So what happens? This is called array representation. Now you may get the doubt, like if you see here in the before we have talked like this is the vector representation and this is the array representation. Now how will you differentiate between vector representation and array representation? So you can if you are confused about it, you can watch my full length video, but I don't want to skip it now. I will also explain it here, but not in a brief manner, just in simple words. I will be explaining how to differentiate between array and vector representation. So basically if you see here, like what is the difference actually, like here a7 down to 0, this is the array representation. Why is it array representation? Because here if you see, okay, a7 down to 0, that means here from a1 to a7, here I am having 8 elements. Okay, that means 8 memory locations are created here. That is what happening here. If you see here, 8 memory locations are created here, and 8 memory locations can hold only single bit. Why? Because here I didn't give any width. Okay, for example, if for the same for the same example, if I have given it like that, 1 down to 0, a7 down to 0. Now what happens? It is having 7 elements where each element can hold 2 bits. Like why? Because a is having the width of 2. So here every element can hold 2 bits, like 1 1 0 1 1 0 1 1. Okay. Similarly, if you are making it 2 down to 0, then every element can hold 3 bits. Clear? So this is how the actual representation, like why is it happening here like in this way, like this is array representation, and if you want to increase the width you should give it before. Okay, so simply we can say that if for array representation, okay, if you are representing array, then it should be after the value, after the particular variable. You can just remember it like that. Okay, it's just some kind of remembrance for you. Okay, how to differentiate between array representation and vector representation is, if the representation is given after, if the width is mentioned after the variable, then it is array. After array, you can just remember it like this. Okay, and the opposite of this, if the representation is before, then it is considered as vector representation. Okay, this is just for remembrance. Okay, but you should also know the reason behind it before going into remembrance. Why? Because these are just tips in order to make you remember when you enter into some interviews or some written test. Okay, because of some tension and because of some other issues also, you may forget, even though the logic you know it, you may forget it. So in such, at such times you can remember by using these tips. But also, even though you remember the tip, you should also know the reason behind it. Like I have told you how, what is the like actually happening, what is the array representation and what is the vector representation, how to differentiate between these two. That is what here. See, a vector is single element that is having n bits. Like if you see here, this count is the single element, okay, which is having 4 bit wide. Now if you see here, count will be 1011. So this is my single element, okay, which is having a 4 bit wide. Now if you see here, for the same array, here this count is not a single element, but here this represents count 0, count 1, count 2, count 3. So 4 elements where each element can hold 1 bit. Okay, if you see here, if you see this example here, having 4 elements, what are those elements? Count 0, count 1, count 2, count 3. Okay, where each count can hold 8 bits, right, where each element can hold 8 bits. Clear? So this is what the differentiation between vector and array. So in Verilog arrays, you are having various kinds of arrays like one dimensional, two dimensional, three dimensional arrays. So this is how you will be representing the array after the variable name. Okay, and when you want to assign the particular value for that particular array, by using that memory location you will be assigning the values. Okay, so you can just pause this and see these particular examples, and if you're having any doubts you can ping me in the comment box, right? And now, so this is about the basics of like what are the things that we need to know before going to write a code in Verilog. So coming to the Verilog module, you already know about the module, right? So what does this module consist of? Like module name, we have already seen it. Ports list, okay. Declarations, like what are the declarations, like input and output ports. And then if it is behavioral modeling, you will be using the always statement. If it is a data flow modeling, you will be using the continue statement. If it is a gate level modeling, you'll be using the gate instantiations, okay. And then direction is nothing but which direction it is, whether it is input or output, right? So now going into the second concept in the module, like if you see, you have seen module name and instantiation. Now coming to ports list. So what is the ports? You already know about the ports, like which port it is. Basically when you are designing anything, it will be having two ports mostly, okay. In Verilog you are having three ports, obviously. Mostly you will be using input output, okay. You're also having another direction which is in out here, okay. So like how you will be declaring the ports, we have already seen this. If you want to declare the ports, you can do it either inside the module, like you can declare the module only with the names of the ports, and you can declare the directions inside the module, or you can directly declare within the parenthesis both the names as well as directions itself, okay. But don't mix and match both things. That means don't declare within the parenthesis, and also inside the module also don't declare it, because it will throw you error. We should use either this method or this method. Don't use the both the methods at a time, right? So this is how you will be declaring the port. Now coming to connections. Connections are really important for ports, because based on the connections only, based, if you see, like when you are connecting some one element to another element, so based on these connections only the data transfer takes place, is it or not? So in order to make your data to transfer correctly from one port to another port, your connections are very important. So you should know compulsorily about this port connections. And also in Verilog you have a chance, if you don't want to connect any port, like in physical format, like when you are physically designing a chip, and when you don't want to connect some port of you, or if you want to leave the port as unconnected, what you will do, you will just don't connect that port. Similarly in coding also, if you don't want to connect any port, okay, if you want to leave the port as unconnected, you can do that by leaving a space between the ports. Like if you see here, actually you should have cout. If you see this is the full adder logic, okay. You should be having the port like cout here. But if you don't want to connect this cout to any other element, so what you are doing, you are just leaving the space here. Clear? You can do that. And now coming to the connections, you can connect it in two ways, okay. Port mapping or port connecting, any other, both are same. Like port mapping by order, by name. By order means, so based on the order, like if you see here, this is my RTL code, okay. This is my TB code, if you see here. So I want to connect my RTL to TB, I want to connect my RTL ports to TB ports, okay. So how am I going to do it? You can do it based on order. So if you are doing it by order, then what happens, how you are mentioning the ports in your RTL, in that way only you should connect the ports. Now what happens, since your port listing you are connecting it by order, so then what happens, sign A is connected to A, out is connected to B, okay. Now for example, if you are doing it in this way, now what happens, out is connected to A, that means here output is connected to input, okay. Input is connected to output. Okay, now what happens? Everything will be mismatched. Like every declaration and every assignment of data, everything will be mismatched. So that is why if you are listing it by order, then you should compulsorily know that how you are mentioning the inputs in order. In that order only, you should be connecting the ports. Okay, if you are connecting it by name, you don't need to follow the order. Now, if you see here by name, like I want to connect this to this. So I am just giving dot A SIG of A. Similarly dot B to out. So I am just mentioning it by name. Since I am mentioning it by name, I no need to mention any other things. Okay. Now coming to the second one. If you see here, I can do this. I can just, if you see here, this is the same order. If you see here, this is, but even though I don't follow the order, now if you see here, B is the second one, but I have kept it in the first place. Even though I have kept it in the first place, it doesn't give you any error or any error output. Why? Because since I am mentioning it by name, so automatically B is connected to out only, even though you are not following the order. Okay, hope it is clear for you. Now writing a test bench in Verilog. How are we going to write a test bench code in Verilog? Okay, so what is actually this test bench? So in the verification, in the starting when design VLSI design process, I have told you verification engineer will be sending the input to the DUT. Okay, so it will be done in the test bench. So test bench is nothing but it is a environment where the functional correctness of your design will be checked. Okay, how will you design, like how will you check this functional correctness? Actually what will happen here is, from your particular TB, okay, from your test bench. So this is my test bench environment. From my test bench environment, I'll be sending the stimulus. Stimulus is nothing but packets of data. Like if you 01011, so this is my packet of data. So I am sending this stimulus to this DUT. So what is this DUT? This DUT is nothing but the RTL code that I am writing. Okay, RTL design, nothing but RTL design. Okay, so I will send my stimulus to this DUT, and here the process will be coming, and then the output is sent to the monitor. Like monitor will be continuously monitoring the stimulus that I am sending and the output that is sending from the DUT. Okay, so in this way you will be sending the stimulus. Okay, so this is how you will be writing the code for, this is my test bench code. Okay, this is my RTL code. If you see here, now you have to remember one thing, whatever inputs that you are mentioning within your RTL code, those should be given as rich. Whatever outputs you are mentioning, those should be given as wire. So y input should be considered as rich, y output should be considered as wire. Okay, I have explained in detail about this in the full length video of how to write a test bench code. Okay, this is that is also there in this particular description box, Verilog HTML tutorial itself. You can check it out, and if you can if you are having any doubts, you can ask me in the comment box, right? Yes, so again, when you are writing a test bench code, okay, the test bench code will be different for combinational and sequential circuits. Why? Because basically for combinational circuits, you don't need to generate the clock. But for sequential circuits, you need to generate the clock. So that clock generation is also done in the test bench itself. Okay, that is why one block is added for clock generation here. Clear? So this is about the test bench code, right? Now coming to the levels of abstraction. So we are having four levels of abstraction in particular Verilog language. Like first, the lowest level of abstraction is switch level, but switch level is not considered in Verilog. Why? Because that is the lowest level where you will be using MOS, like PMOS and MOS circuits. But when you are entering into the real time field, we don't need to go to that low level of PMOS and NMOS in order to design a circuit, because you will be designing a complex circuits. Okay, when you are using a complex circuits, you don't go for this PMOS and NMOS things, right? So that is why the switch level is almost avoided in case of Verilog. Okay, in Verilog you will be starting with gate level, which is considered as lowest level for Verilog. Okay, so gate level is lowest level and behavioral level is the highest level. So in gate level, by using the gates, logic gates like AND gate, OR gate, NAND gate, so based on all these gates you will be writing the code. Okay, in case of data flow modeling, based on the flow of data, like based on how the data is flowing between your registers and based on the operators, you will be writing your code in case of data flow modeling. And in case of behavioral modeling, based on the behavior of the circuit, like how your circuit is behaving for a set of inputs. So keeping that in mind, you will be writing the code for behavioral level modeling, right? So coming to gate level modeling, here if you see, as I already told you, that this is the lowest level of modeling. Okay, and here you will be using, in case of gate level modeling, you will be using gates in order to write your program. Okay, so based on the structure, that is why this is called a structural level also. So based on the structure, you will be writing the code. So these are the basic gates you will be using. So all these are called as gate primitives. Like these all gates are already inbuilt in the Verilog. Okay, what you need to do is you need to just call this gate and you need to write a program using this particular gate primitives. Okay, so these are the gates that are already inbuilt in the Verilog. Okay, and when you want to call this gate, you have to, as I already told you, since they are already inbuilt, so they will have certain syntax. So you need to follow that syntax in order to call your that particular gate into your code. Okay, so these are the syntaxes for, like, for any gate. First you should mention the output, then the input. Okay, that is the simple logic here, right? So these are certain gates. Okay, you already know about this. You can just pause the video and check out all the gates if you are interested in this. Okay, so I'll show you a small example here. Okay, here we are writing a program for gate level program. Okay, gate level code for half adder. So as I already told you, since you are writing it in a gate level modeling, the most important thing in case of gate level modeling is the structure. Okay, the structure of your circuit. So this is my structure. So based on this structure I'll be writing my code. So if you see here, what does my structure consist of? One AND gate and one XOR gate, right? So based on this AND and XOR. Okay, so for everything you should be considering the output. So what is the output? First output is sum. A and B are inputs. So sum A comma B, and you will be mentioning with some individual names. So gate, name, and input and output ports. Gate, name, and input and output ports. Simple, just as simple as that. Okay, so between module and main module you will be creating a name and then input and output ports, and then you will be writing, calling the gates and writing the code. That's it. So if you see here, what is the most important thing in order to write your code? This is not the logic that is important, but the gate structure that is important. Clear? So this is for marks. Okay, you can just pause this video and check the logic for this also. This is for full adder. Okay, here I am using instantiation topic. Okay, you can just pause this and check out, and if you want a explanation of this particular thing, you can go into my full length video where I have explained clearly about how this instantiation is taking place and how the port connection is being done, right? And this is how you will be giving the stimulus. Okay, these are delays. So this is how you will be giving the stimulus through your test bench. Clear? Yes. Now coming to data flow modeling. So in the gate level modeling, you will be writing the code based on the gates, based on the structure. But in case of data flow modeling, what you will be doing, you will be writing the code based on how the data is flowing. That is why this is called as data flow modeling. Like how the data is flowing between your particular registers. Based on that, you will be creating this data flow modeling. Okay. So in this data flow modeling, the most important thing is you will be using the assign keyword in order to write a logic. Okay, so in order to use this assign keyword, you have to follow certain rules and characteristics. So what is that? Here if you see here, assign LHS is equal to RHS. LHS equal to RHS means, for example, if you are writing for AND gate. Okay, so what is this is my AND gate. Okay, A and B are input, C is output. So what happens? Assign C equal to A and B. By using the operator symbols, you will be writing the code. Okay, assign C equal to A and B. Now this C is my LHS and this A and B is my RHS. Okay, so this LHS and RHS, where you are mentioning the LHS and RHS, you need to remember some important concepts. What is this? The LHS of an assignment must always be vector or scalar. It cannot be vector or scalar register. It should be only net. Okay, that means this C should always be wire data type but not rich data type. You should remember that thing. Okay, the RHS can be of any data type, but the LHS should only be wire data type but not rich data type. So why is that also I have explained clearly while I explaining the data flow modeling. You can go there and check it out, right? So that is one condition. RHS can be of any registers, like it can be of net or any data type, but LHS should always be wire. Okay, so here what happens when you are using assign keyword, as soon as the logic like A and B operation is done, then the output is immediately assigned to C. Okay, if you are having any delays, you can also use the delays in case of data flow modeling, right? So you'll be, if you see here, this is my logic. I have told you that I have using the operator. So in this way you can use all these operators in order to build your logic in case of continuous assignment, which is the data flow modeling. So this data flow modeling is called, in this the continuous assignment is being done. That means the assignment is done continuously to this particular LHS and RHS values. Clear? So these are the operators that you will be using, like arithmetic. So you already know about, in order to perform arithmetic operations, you will be using the arithmetic operators. And in order to perform logical operations, you will be using logical. So this is logical negation, logical and logical or. And in order to perform bitwise operations, you will be using the bitwise operator, where these are the notations for bitwise operations. Okay, like and or. Okay, you should know, you should also consider the difference between logical and bitwise and. You should remember these particular operations. That is why I have created a separate slide for this, or else I would have just explained it by taking everything in a within a single flow. But in order to make you also know about these operations, because when you are writing a logic in case of data flow modeling by using operators, the most important thing you should consider is the operator symbol. Operator symbol is very important, even though it seems to be very easy, but it is also a very confusing concept. So that is why, so if you are interested, you can just write a note by take a snap of this particular operator symbols. Okay, and then coming to equality, again in equality you are having two types of equality. One is equality and the second is case equality. Okay, so the difference between the equality and case equality is, equality will be having four outputs, like the output can be either 0, 1, x or z in case of equality operators. But whereas in case equality operators, the output can be only 0 or 1. You don't have x or z outputs in case of case equality. Like why? Because even though there are x and z values in, when you are using the case equality operator, then it will be comparing the x and z values also, so that you will be having only 1 and 0 as outputs. Okay, in order for detailed explanation, I have explained in detail about all these operators in my video. You can go check out there. Right, next is relational. In order to know whether a particular two inputs are greater than or less, in order to have a relational operators, you will be using a operation, perform relational operation, you will be using this relational operators. And for left shift and right shifts, you will be using, so this is the operators for. Again here for left shift and right shift also, this is logical left shift, logical right shift. Okay, and this is arithmetic left shift and arithmetical right shift. You should consider that. Okay, you should also remember, like 2 means it is logical shift and 3 means that is arithmetic shift. Okay, now coming to reduction operators. Okay, so if you see here, these are similar to that of bitwise operators. So how will you differentiate between the bitwise operator and reduction operator? Okay, so basically in case of reduction operator, there will be only one output, like only in single bit, either 1 or 0 only one output will be. But in case of bitwise operator, okay, that won't be the case. Like if, for example, if you are compare, like if you are ending these two cases, okay, in case of what is, in case of bitwise operator, you will be having the output in a 4 bits. But in case of this particular reduction operator, you will be having only 1 or 0 as output, only single bit, not multiple bits. Okay, why is that? Like how the reduction will be taking place in this reduction operator, you can go and check that in the full length video, right? Now coming to conditional operators. Okay, for conditional operators, if you see here, you will be using the logic. This is the main logic here. Okay, so the result equal to conditional expression. For example, here I am writing A and B question mark 1 semicolon 0. Now what happens if A and B is true? Okay, like for example, A greater than B. Okay, this is my condition. Okay, now what happens if A is greater than B, then the output will be true. If this is true, then the first expression is printed. If this is false, then the second expression is printed. Clear? So this is how the conditional operators will be working. And also you can do nested conditional operators also. Okay, that means within one conditional operator you can write other conditional operator also. That is called nested conditional operator. Okay, you can do that also. You can check that in the full length video. Okay, here I'm mentioning everything not in detail, but in order to, since everyone are familiar with, if you are familiar with Verilog, you will be familiar with all these operators. So I don't want to waste time on detailing explaining about these operators. So that is why I'm just telling like what are the, how the operator symbols will be there and what are the basic operation of these operators. Okay, and now coming to concatenation. So from the name itself you could say, if you want to combine some two or three variables in one place, then you will be using this conditional operator. For example, a b c. Now if you are using this a b c, now all the variables within all the values within this a b c will be combined and you will be grouped together. Okay, so if you want to group two or three elements at a place, you will be using this concatenation operation. And then coming to replication, if you see here, concatenation is having two braces and replication is four, right? So replication means it is just to replicate. What is the meaning? That means if you want to print the same for two or three times continuously, same value for two or three times, then you will be using this particular replication operator. Clear? Yes. And then delays and continuous assignment, you can also use as a, we told you before itself, while you are writing a code in data flow modeling, you can also use delays. Okay, and again in delays you can have two types of delays mostly, because net declaration is not considered as most important thing. Mostly regular and implicit, both are same. Okay, both, there won't be any change in the delays, but in the notation itself, like in regular assignment delay, you will be giving the delay before the particular output variable. That means before LHS you will be giving the delay. But in case of implicit continuous delay, okay, here itself you will be giving the delay. Like at the, instead of writing SN, you will be writing this particular result equal to IN1 to 5. Okay, so this is the notation. Like you have to remember this notation. If this is regular delay, you have to give it by using SN keyword. If it is implicit, that means implicit means within inside you are giving the delay. Okay, for that you don't need to use the SN keyword. You can just directly give the hash wave. So behavioral modeling, how are we going to write a code? Like based on how the design, how your design is behaving for your particular inputs. Okay, so based on the behavior of your circuit, you will be writing the code in case of behavioral modeling. And also the gate level modeling is considered as the lowest level of modeling in Verilog, because which level is already removed in case of sorry, in Verilog language. So mostly we'll prefer gate level as the lowest level of abstraction and modeling, behavioral level modeling as the highest level of abstraction. Because while we are designing for complex circuits, okay, we'll mostly opt for behavioral modeling than that of this data flow modeling and gate level modeling. So by in when we are taking it simply, what we do is when we are analyzing a combinational circuits, we will go for data flow modeling, and when we are analyzing the sequential circuits, we will be opting for this behavioral level modeling. Okay, simple, in simple. That doesn't mean that combinational circuits can only be written in data flow modeling and the sequential circuits can only be written in behavioral modeling. But mostly when we opt for writing the coding styles, we use data flow modeling for combinational circuits, and we use this sequential circuits for behavioral level modeling. Okay, so as we all discussed that behavioral modeling, in behavior we will be writing the code based on the behavior of the circuits. Okay, so in this behavioral level modeling, it consists of some procedural statements. Okay, so which are used in order to control the simulation, right? So basically when it comes to behavioral modeling, we will be doing it with the help of procedural blocks. So we can say that behavioral modeling consists of some structured procedural blocks. Okay, so again, this structured procedural blocks in behavioral modeling is categorized into two parts. Like one is initial block and the second one is always block. So In behavioral modeling, these two blocks are very important. We should know everything about initial block and always block, because whatever code we are writing in case of behavioral modeling, like whatever we are writing in the RTL code or whatever we are writing in the test bench code, we will mostly use these two blocks, which is initial block and always block. So let us know some details about this initial and always block. Okay, now coming into initial block. So in this initial block, as the name says, it will be executed only once. Okay, when the simulation is being done, when the code is being run, it will be executed only once. This initial, so whatever code that you are writing within the initial block, that will be executed only once. And also this initial block is non-synthesizable block. That means it can't be used for RTL, like it can't be converted into hardware description like hardware. That is why mostly we'll use this initial block in test bench. Okay, and this initial, when we are writing the using this initial procedural block, okay, we'll be using the keyword called initial. And in initial, if you want to write a code which is more than one statement, like if your code consists of more than one statement, then you should use the keywords like begin and end. So within begin and end, you should be writing your entire code in the initial block. And also in Verilog code, in your Verilog code, you can have any number of initial blocks. Okay, there is no rule that you should only write one initial block within your particular code. Okay, you can write any number of initial blocks, and also while you are running the code, all these initial blocks will be running parallelly. That means everything will be started at zero simulation time. Okay, so if you are taking some 10 initial blocks, all these 10 initial blocks will be starting at zero time unit. Okay, in case of initial block. And also one thing you should avoid while you are writing this initial block is you shouldn't use nested initial block. That means you shouldn't use one initial block within another initial block. This should be avoided in case of initial block. Okay, and also you can use delays in the initial block. So this is about the basic idea of what is initial block. So when you're writing an initial block example, so this is how you will be writing. Okay, you can have any number of statements. If you have more than one number of statement, you will be using the begin and end. Okay, and when you are writing the initial block, if you are writing some three initial blocks here, all the three initial blocks will be starting at zero time step. Okay, so this is how, see here you are writing two initial blocks, so both of these initial blocks will be starting at zero time step. Okay, but based on the delays you are using, the time will be changing. Got my point? So this is about initial block. Now coming to always block. Okay, so it is similar to that of initial block in some cases, but differs in some other cases. Like if you see initial block, that will be executed only once, but this in a always block, this can be executed any number of times. Like if you want to execute it any number, some 10 number of times, it will be running for 10 number of times based on the condition you are giving. Okay, so that is important here, right? And also one more difference in case of initial and always block is synthesizable. So which is why we mostly use always block in case of RTL code, and we'll use initial block in case of test bench writing. When you are writing a test bench code, you'll be using the initial block, and when you are writing the RTL code, you will be mostly opting for always block. But this is not the rule. You do like that, basically that is what I'm telling. Generally when you are generating some clock, okay, in such cases when you want to repeat the execution for n number of times, you will be using this always block. Okay, just like initial procedural block, you will use the initial keyword. In this always procedural block, you will be using always keyword. And similarities, when it comes to similarities, both initial block and always block also, if you have and like multiple number of statements, you will be writing them within begin and end blocks. Okay, and similarly both in initial and always block also, you can write any number of initial blocks and you can write any number of always block. And same like initial block, if you are writing some three initial blocks, all the initial blocks will be running concurrently. Similarly, in always block also, if you are writing for three always blocks, all the three always blocks will be running parallelly based on the delays that you are giving. Okay, these are the similarities and these are the differences between always and initial block. Okay, so, as I told you, when it comes to always block, it will be running n number of times. So, how to make it run for n number of times? Okay, so basically, when will this always block will be executed? So, this always block will be executed when there is the sensitivity list. Okay, when there is any change in this particular sensitivity list, then only this always block will be activated. Okay, it will be represented with @ symbol. Okay, and whatever you are writing within this parenthesis, generally when you are going for always block, the syntax will be in this manner: always @ okay, star. Basically, if you see any code, it will be mentioned as star. Okay, only some cases you will be seeing like @ of posage of clock, @ of negage of reset. In that way you will be seeing. In most cases you will be seeing that as a star. Okay, so what you are writing within this arguments is called as sensitivity list. So based on this sensitivity list only, this always block will be activated. Okay, for example, if there is no sensitivity list, what happens? So if there is no sensitivity list, then the always block will be executed repeatedly and it will enter into the zero infinite loop, like it will be running forever. Okay, so until it enters into zero infinite loop, it will be running and your program will be hanged. So that is why mostly you will be using the sensitivity list. So what does the sensitivity list consist of? Nothing but conditions. Okay, some conditions in order to activate your particular always block. For example, always @ of posage of clock. If you are giving like that, now what happens? Okay, whenever there is posage of clock, then only this always block will be activated. If there is negage of clock, then this always block will not be activated. So that is the important of sensitivity list. Sensitivity list means it is the control for the always block, because always block will be executed for n number of times. So in order to control it, okay, in order to not to allow it to go into the infinite loop, we will be using the sensitivity list. Hope you got an idea on what is sensitivity list or how important it is in order to activate this when you are using the always block. Okay, so this is the thing. And the most important thing that you should consider, what is it? That here this you will be having a sensitivity list. Okay, so this is how the always block will be written. Like if you have only single statement, no need of begin and end, but you are having multiple statements, then you should be writing it within begin and end, always @ sensitivity list. Okay, so this is the small example in order to generate the clock. Okay, for example, while you are generating the clock, it is like it should always be until your program will be continued. Okay, it should always generate a clock. Okay, here I am taking the clock with 5 time period, like my posage will be at 5 time units and my negage will be at 5 time units. So the total time period of my clock is of 10 time units. Okay, so this is about the always block. This is how you will be generating the clock. Okay, in the by using just the always block. Clear? Hope this is clear about this particular behavioral modeling blocks, procedural blocks like initial procedural block, always procedural block. Okay, now coming to procedural assignments. So what is this assignment? Before going into the procedural assignments, let us see what is Verilog assignment. So what is the meaning of assignment? Assignment is nothing but put some values into your particular variable. For example, I am telling that a equal to 5. Now what I am doing, I am assigning the value 5 to my variable a. Okay, this is called as assignment. Okay, and also in Verilog you are having some two kinds of assignments. Basically it is called three kinds of assignments. Okay, one is continuous assignment, second is procedural assignment, and the third one is procedural continuous assignment. Okay, now coming to what is this three assignments, like what is continuous, what is procedural, what is procedural continuous assignment. So basically, continuous assignment is nothing but assignment that you see in the data flow modeling. Okay, in the data flow modeling, how the assignment takes place, like you will be assigning some, for example, by using a keyword assign. Okay, assign some C equal to A plus B, right? Like this is called as LHS equal to RHS, is it or not? So this is what the assignment is there in data flow modeling. So this type of assignment is called continuous assignment. Okay, now if the for this same thing, if you are doing like without using the assign keyword, if you are giving it like less than or equal to A plus B, this is called procedural assignment. Okay, so this is the procedural assignment and this is the continuous assignment. Clear? So again, in procedural assignments also, basically you are having two kinds of assignments, like one is blocking assignment and another one is non-blocking assignment. Okay, so basically what happens, what is the difference between the continuous assignment and procedural assignment? For example, if this is the continuous assignment, what happens means, as soon as the operation like A plus B is completed in the RHS, that means as soon as the RHS expression is completed, then immediately the value of A plus B is assigned to C. Okay, until and unless it is not assigned to C, it won't go to the next step. So that is what continuous assignment means. Again, in procedural assignment, okay, you are having blocking and non-blocking assignments. So in both of these assignments also you'll be having the difference. So let us see that what is the blocking assignment and what is the non-blocking assignment. Basically, if you see, continuous assignment and blocking assignment are same. Okay, so blocking assignment is given with a keyword like equal to. Okay, and non-blocking assignment is mentioned with this symbol. Okay, so this is the symbol for blocking assignment, this is the symbol for non-blocking assignment. So what will be the difference between these two statements, like what is the exact difference between blocking statements and non-blocking statements? Okay, let us see with an example here. See, this is how basically now if you see this particular symbol, you have seen it somewhere. If you see, this is a relational operator also. This symbol is used as less than or equal to relational operator, and this symbol is also used as an arrow for non-blocking assignments. So how can the system compile the see the difference between if it is a relational operator or if it is a non-blocking assignment? So basically, when you are using it in between the expression, then it is interpreted as a relational operator. Okay, if you are using it for assignment, like if you are using it for assigning some value, then it is interpreted as non-blocking operator. Okay, hope you got the difference. Why? Because in interviews it may ask like what is the difference between this as a relational operator and as a non-blocking operator. So basically, when you use it in between the expression, then it is a relational operator, and when you use it to assign some value to a variable, then it is a non-blocking operator. Okay, now let us see what is the difference between the blocking assignments and non-blocking assignments in one shot. Like with one simple example and one simple sentence, I will tell you the difference between the blocking and non-blocking assignments. So let us see this particular example here. Okay, x equal to a less a or b. Okay, y equal to a x or b x or c. Z equal to b and negation of c. So I am writing this as a non-blocking assignment. For example, if you are using it a blocking assignment, then what happens means, okay, after the completion of A or B operation, first let us consider it as a blocking statement. Okay, now what happens after the completion of A or B, the value is assigned to X. Okay, after the value is assigned to X, then the operation of AX or BX or C happens. Okay, now what happens after the completion of AX or BX or C, the value is assigned to Y, and then after assigning it to Y only, that means after completion of assigning RHs to LHs, then only the second statement starts. In the second statement, after assigning the value from RHs to LHs, then the third statement starts executing. That means B and negation of C operation takes place after completion of this particular variable. Okay, now what happens? When will this be executed? Okay, when after execution of this particular variable, then it is assigned LHS, then only it will be coming to the next statement. So what is it happening here in case of blocking statements? Until the execution of one statement, the remaining statements are being blocked. Okay, so because of this reason, it may give a point of raising to raise around condition. Okay, which is a big default in case of blocking statements, right? So in order to avoid this race around condition and everything, we have opted for non-blocking assignment. So the same thing, when you come for non-blocking assignment, what happens means, first all the RHS expressions are being executed without assigning any value to LHS values. Like if you see here, ERB is executed and then it won't be assigned to X, but it will be executed. Similarly, AX or BX or C is executed. Next, B and negation of C is executed. So all the RHS expressions are executed, but the assignment takes at the end of the last step. Like if you see here, after executing B and negation of C, and after confirming that there are no more statements behind this, then only the values will be assigned to X, Y, and Z concurrently. So this is what the non-blocking assignment does. Okay, hope you got an idea on what is the difference between blocking and non-blocking assignments. So why? What if you are using a non, as I told you, what if you are using a no blocking statement, and what is the race around condition, or what are the advantages in case of using non-blocking statements? Okay, when you have certain conditions, let me put a certain condition for you, okay, before you, so that you can understand clearly what is the difference. Why should we go for non-blocking statements even though we are having the blocking statements? Okay, now let us see some example here. Here I am assigning A value as 1 and B value as 0. Okay, here I am writing two always blocks parallelly. Now, if you know, as we have discussed before, if you can have any number of always blocks within your code, and all these always blocks will be running concurrently. So, if you see here, both these always blocks will be running concurrently. Now, what happens? Since if you are using a blocking statements until the execution of the, okay, now what happens, either this or this will be running at zero time, that at starting time. Okay, at zero time units both will be running parallelly, but the execution, the compiler will may execute the first statement first or the second statement. Now what happens, for example, let us consider if this passage is taken as the first passage of clock. Now what happens here, you will be having every passage of clock. Okay, so at first passage of clock, if you are thinking that this always block is activated, now what happens, what is there in B that is assigned to A? Now what will be the value of A will be 1. Okay, now after this thing, the second thing will be starting to execute. Now what happens, what is the value of A here? Actually the value of A is 1 here, and the value of B is 0. Okay, now if you see here, A is 1, okay, and B is also 1. Okay, so what is happening actually when you want to flip these values? Like I want, okay, I am writing a code in order to flip the values as A equal to 0 and B equal to 1, from A equal to 1 and B equal to 0. But what is happening here? Both are getting the values as 1. Okay, for example, if you consider this is activated first, now what happens here? A equal to, what is it? A equal to 1, so that is assigned to B. So now what happens? A is also equal to 1. So similarly, in this way, based on the values, only one value here, no flipping is done, but only the value is getting, either both are ones or both are zeros. Now if you are using the non-blocking statements for the same statement, what happens? Okay, here if you see, A is non-blocking statement assignment to B is non-blocking statement assigned to A. Since you all know that before assigning anything, only first the values will be assigned to this RHS. Okay, now what happens, B value will be 0 is assigned here, but it is not assigned to A. Okay, similarly A value is 1 is placed here, but it is not assigned to A. So after completion of everything into RHS, then the LHS takes place. So now what is the value of A? 0. What is the value of B? 1. If you see here, which is the flip-flop of this particular answers. This is what I needed. So in such conditions, like when you want to assign some values or when you want to flip some values, okay, in such conditions there may occur a race around condition which can be avoided by using this non-blocking statement. Okay, hope you got an idea on what is blocking and non-blocking statements. Okay, so let us see the some internal procedure, like what is happening if we are using the blocking and if you are using the non-blocking. Why is this happening? Like if you see here, why the same value is attaining in case of blocking statement and why the flip-flopping is being done in case of non-blocking statement. Let us see here. Here I am taking like three values. If you see here, q1 equal to in, the same thing here, the logic is same. If you see here, okay, for both things the logic is same. What I am doing, I am using a blocking statement in one thing and non-blocking statements in another program. Like if you are using the blocking statement, what happens? For example, let us consider the values, like the basic value, previous values. Okay, some in equal to 1 and q1 equal to 0 and q2 equal to 1. Let us consider these are the three values. Now what happens? What is there in in is assigned to q1 immediately. Okay, so what is there in i1? 1, that is assigned to q, so q1 is 1. So after execution of this statement, then only that comes to the second statement. So what is the q1 value? It is 1, that is assigned to q2. What is q2 value? 1, that is assigned to 1. So what is actually the output? Output is nothing but the input. What is there in input, that is assigned to output. Now what are these registers? There is no intermediate registers here. They are just a passing. They are just a points in order to pass the values. They doesn't contain any value in such statements. Okay, now if you are seeing the same thing here, what is in here? In is actually 1. Okay, in is 1, but that is not assigned to q1. Okay, first you already know that in non-blocking statements all the left hand, all the right hand side execution will be taking place first. So what is q1? 0. What is q2? 1. So after having initializing all the values on the RHS, then the assignment takes place. Now what happens? q1 1 equal to 2, q2 will be equal to 0, okay, and out will be equal to q1. So in this way the serial execution, like serial input serial output, here no serial input no serial output, only what is there in input that will be there in the, what is there in input that is there in the output. That's it. There are no serial cases in case of this blocking statements, but in case of this, whatever that is there in input, that is first going to q1, what is that is there in q1, that is going to q2, and then from q2 it is going to output. So in this way actual serial input serial output stage is working out in case of non-blocking statements, which is an utter flop in case of blocking statements. Hope you got an idea. Like this is how, like if you are using a non-blocking statement, three flip-flops are being created, but when you are using a blocking statement, only one thing, the intermediate connections are just, if you see here, x and y doesn't contain any value in case of this particular non-blocking, sorry, blocking statements. Okay, hope you got an idea. Like this, you see, before we have explained, see, three D flip flops are created. Like here you are having three things, so three flip flops are being created. But here in non-blocking statements, even though you are having three flip flops, only one flip flop is being created, which is a big failure in case of blocking statements. Which is why when you want to assign, like when you want to design some circuits which are based on like serial input and serial output or in such way, so when you are designing such things you mostly prefer for non-blocking statements instead of blocking statements. So these are certain differences for blocking and non-blocking statements. Okay, you can pause this video and you can study the differences. I have already explained all the differences, and also in clear explanation, like I have given some two or three explanations for blocking and non-blocking statements in detail. Okay, in my Verilog HTL tutorial videos. Okay, I link the Verilog HTL tutorial in my playlist in my particular description box. You can go there and check out all the videos on Verilog if you are a fresher and if you are not at all familiar with Verilog. Okay, After seeing this video, try to check on in detail about every concept in my particular Verilog HDL tutorial, right? So this is about the blocking and non-blocking statements. And just like in data flow modeling, you will be using delays. In this behavioral modeling also, you will be using delays. Okay, in behavioral modeling, you are having like two kinds of delays. One is delayed assignment and another is intra-assignment delay. So delayed assignment means at the starting itself, like at the during the starting of the expression itself, you will be giving the delay, like the hash delta t. Okay, when it comes to intra assignment delay, okay, with expression only, with you will be within the expression, you will be in intra assignment, that means before assigning only you are giving the delay, but here delayed, that means after assigning the value to the variable, then you are giving the delay. Okay, so this is about the delayed assignment and intra assignment delay. Like, what is the difference between the delayed assignment and intra delay assignment? Okay, just simply I'll give you a small example for you. Here, if you see this, this is the delayed assignment and this is intra assignment delay. Like in case of delay assignment, what happens here? If you see the expression c equal to a or b, now what happens? A or b will be getting evaluated at 20 nanoseconds, and then it will be assigned immediately to c. Okay, in case of intra assignment delay. Whereas delayed assignment, what happens? Sorry, in case of delayed assignment, in case of intra assignment, what happens here? The execution is done, okay, gets evaluated at time before, and that means here, since it is having 20 nanoseconds, so at that particular time only the execution is happening, but the assignment takes 50 time units of delay, that means 50 plus 20 70 time units of delay for assigning some value. Okay, that is the difference between intra assignment delay and delayed assignment. If you want to know clearly about it, I have already explained about that in the particular video in the Verilog tutorial. You can go there, check it out. But this is the major difference between delayed assignment and intra assignment delay. Okay, now, as we already discussed in the data flow modeling, like by in data flow modeling, you will be using the operators in order to create the expressions and you will be writing the code. Similarly, in case of behavioral modeling, okay, you will be using conditional statements and also you will be using some other things. Like first thing, you will be using the conditional statements. So in conditional statements, you are having two kinds of conditional statements, and by using the loops, okay, by using conditional statements and loops only, you will be writing the behavioral level modeling, right? So in behavioral modeling, if you see, you will be using two conditional statements like if else and case statement. Okay, you can just check the syntax of this is if else if. Okay, I have already explained this about conditional statements also in my Verilog HTML tutorial. If you are interested in knowing about the statements like conditional assignments, case statements and everything, you can go check that video, and if you have any doubts, you can ping me in any of my social media handles. I'll be available at any point of time if you are having any doubt, right, regarding subject. So this is about the case statement. So this is how you will be writing the case statement. Okay, now coming to, so when you are using sequential circuit and when you want to write a case statement, so this is the program for generate for creating the JK flip flop. Okay, the RTL code for JK flip flop. Right, if you have, you can pause this video and check out this particular program code on JK flip flop. And if you are having any doubt, you can ping me. Right, then you will be in Verilog along with conditional statements. You will be using the loops like for loop, while loop, forever loop, repeat loop. So these are the most frequently used loops in case of Verilog. Okay, for loop you already know, this is the syntax for loop. Okay, right, now coming to while loop, so this is how you will be writing the while loop expression, and this is the syntax for that particular thing. And then coming to forever loop, like if you want to execute some particular code or some particular statement for n number of times, okay, for they will call it as forever, but if you want to repeat it for some many number of times, you will be going for this forever loop. That means it will be running forever until you give some constructions like dollar finish or anything. Okay, until you give the system task like dollar finish, it will be running for foreverly. Okay, so this is how. See, if you see here, I have given like hash finish dollar finish hash $10 finish. That means until I am giving at 10 time units. So if you see from 0 to 9, the iterating statement is being printed for n number of times until I have given the $finish. That means in order to break the forever loop, you have to use the system task $finish. Okay, so this is about it. And then repeat loop. Like if you see in forever loop, it will, if you don't give any particular $finish, it will be running forever. But in case of repeat loop, it is not like that. Repeat means you need to give it a condition, like you should repeat it for five number of times, for 10 number of times. So in this way, you should be mentioning the number in order to make that loop to repeat. Okay, so that is the main difference between forever loop and repeat loop. Right, now coming to the one of the major concepts in Verilog, which is Verilog tasks and functions. Okay, tasks and functions have some similarities, have some dissimilarities also. So anything, either it is a task or a function, it is nothing but when you want to use a certain group of statements, like certain piece of code at for 4 or 5 times in your particular code, then you can write that piece of code within the function and end function, and then it becomes a function. So you can call this function with that particular name at any point of your time or at any point of your code. Okay, so that is about Verilog functions and tasks. Hope you got an idea on what is Verilog functions and tasks. Okay, simply we call this task or function as a subroutine. Okay, so subroutine is nothing but it is a piece of code where you will be writing at some point of time, and when you want to call it, you can call it with name at any part of your code. Okay, so this is how you will be writing the function in case of Verilog. This is syntax like function. Okay, for you, if you are not giving any automatic keyword, it is by nature static in nature, like function, return type, name, and then arguments. Okay, arguments means nothing but the inputs and outputs basically. And then if you are having many number of statements, you will be writing within begin and end. Okay, and then within this you will be writing the function definition, which is nothing but the piece of code which you want to repeat for n number of times. Okay, and then n function. So this is how you will be writing the function. Like the main important thing you should consider is first you should declare the function in order to call it. Like if you are calling it and if you didn't declare the function, then the compiler know where you have you written that function and where are you calling it. So that is why in order to call the function, you have to first declare it. So this is how you will be declaring the function, like function, return type, name, arguments. And this is called the definition. Definition is nothing but the logic that you are using. Okay, the piece of code that you are writing. So when it comes to defining the functions, you can do it in two ways. Like you can give the inputs list, like input and output ports within the arguments itself, or you can just declare it within the function. Like inside the function, you can declare the list and you can write that particular code or expression. Okay, so this is how, see if you see here, you can either give this input a comma b here itself by using the arguments in this way, or you can explain it within the function. Okay, and then you will be writing the actual code, which is this particular line, sum equal to a plus b. So this is my particular function which I want to call it. So see, this is the example. See the same function here, a and b. Okay, sum equal to a plus b. So this is the function return value. Okay, if you see here, when it comes to the calling function, like this is the part of code that you have written at some place of your program, and if you want to call it at some place of your time, how can you do it? Like if you see here, a equal to 4 and b equal to 5. Here actually the given thing is a equal to, here you have just written a equal a and b, and you are writing the function here. Now when you want to call it, you should call it with the name of that function. Here the function name is sum. So I'm just calling sum equal to a comma b. Now what happens? A equal to 4 will be assigned to a and b equal to 5 will be assigned to b. Okay, so this is how you will be calling a function. Okay, so this is how you will be writing the function, like this is my function. Okay, this is how you will be declaring the function, and then this is how you will be calling the function, like this is my function addition. Okay, and you will be calling it like this. Clear? Right? Hope it is helpful for you. Now coming to Verilog function rules. So while you are defining function, you should follow certain rules before defining any function. Okay, which is considered as once as advantage and sometimes as disadvantages while you are using the functions. So the first thing is Verilog functions can have one or more input arguments. Like you can have one or more input arguments in case of Verilog functions, and functions can only return one value. Like when you are writing the functions, it can only return one value at a time. Okay, and also one important thing while you are writing functions is functions should not use any time consuming constructs. Like you shouldn't use at the rate of passage of clock or delays, or you shouldn't use non-blocking statements in case of functions, because all this will be representing some time delays, which is not possible in case of functions. Okay, so when you are using when you are using any time delay constraints, it is better to use task instead of function. Okay, and when you want to use any non-blocking assignments also, you can't use function, so that is why you can use task there. Okay, and one more important thing is we can't call other function from within, sorry, we can't call task from within function. That means by using a function you can't call task, but by using a task you can call function. Why is that? Because task can have non-blocking, or task doesn't have any rules. Like only these rules are limited to functions itself. When it comes to task, you can write it in any way. Like it doesn't no need to consist of any inputs, or it can have any number of inputs, or it doesn't have any inputs, or it can return any number of outputs at a time, or it can have many, like it can have any passage of clock or any delays, it can use any non-blocking assignments. So that is why when you want to write a liberal code without any following any of these rules, you write it as a task. And when you want to write a code which is below all these function rules, then you can be opting for function instead of task. Okay, so this is the particular functional rules about the functions. Okay, when now coming to task, as we already discussed in the before thing itself, like when you want to use any delays or any passage of clocks, and when we can use both blocking and non-blocking statements. So mostly when you are using any time consuming constructs, you can go for task instead of functions. Okay, and can as I told you, Verilog task can have any number of inputs, and it can generate any number of output also. Okay, so these features means tasks are best to implement. That is why since it doesn't have any rules and it is easy to write, mostly we go for tasks in any program instead of writing it by a function. Okay, so this is how you'll be. So if you see here, without any inputs also you can write a task. Okay, task sum, right? So this is how you will be writing your task. Clear? So these are some of the advantages, sorry, these are the some of the difference between task and function. Just pause this video and check this particular table so that you will get the difference between what is task and function, which is very important in case of Verilog. Okay, because if you know about this task and function only when you take a step forward in your design and verification domain, like if you want to learn some system Verilog courses also, there also here task and functions are very important. So that is why you just see the differences between task and function, which is the most frequently asked interview question also. Like they will be asking at least two or three differences between tasks and functions. So that is why try to remember these particular differences between tasks and functions. And when you are reading it, if you are having any doubt, you can ping me in the comment box. Okay, and now coming to the compiler directives, which is also a major thing in case of Verilog. Like compiler directives are nothing but they are which are based on like you will be seeing these compiler directives in any programming language. Basically they are based on compilers. Okay, so they will tell how the compiler will compile the code. Like basically they will tell you how the compiler is compiling the code, and in Verilog you are having various compiler directives. Okay, if you see when you are defining a compiler directive or when you are writing a compiler directive, it will be given by a backslash symbol. Like tick will be called as tick. Okay, tick define, tick include, tick if def, tick if and def, tick else if, tick else, tick time scale, tick and def, tick reset all, tick default net type. So from the name itself you can grab the knowledge on what is the work that they will do. Okay, so coming to tick define, when you want to define, so basically it is similar to that of parameter, but in parameter there is a chance to override it during the runtime. Okay, so similarly tick define is nothing but it will be defining something. You can say that when you want to define a particular macro or constant or particular variable. Okay, so basically you will do that by using the tick define symbol. Okay, and when you want to particularly undefine it, you will be using the tick undefined compiler directive. Okay, so tick if define, yeah, sorry, tick define is to define the particular variable or particular macro, and tick undefine is to undefine that particular macro what you have defined already. Okay, in order to use the undef, first you should use def. Okay, until and unless you don't define it, you can't undefine it. I hope you got the this small logic. Okay, so what is the tick def and tick undef? And then coming to tick include. So from the name itself, if you can say, if you want to include any other files within your particular files, then you can use this tick include. Okay, similarly, tickfdef, tickifndef. Tickfdef is used in order to check whether you have defined that particular constant or particular macro. Okay, when you're writing the code and at some part of your code, if you want to check whether you have actually defined that particular constant or that particular macro, you will be using the ifdef. Okay, and here then if endef means if not defined. Okay, if you don't define that particular keyword or particular constant, and if you want to include something, like if you see here, if you have defined something, you need certain work to be done. If you don't define it, you need certain another work to be done. So in such cases, that means if you are defining that particular constant, that some particular piece of code is to be executed, and if you are not defining that, other particular piece of code need to be executed. It is very similar to that of if else. Okay, so basically in such conditions you will be using if def and if and def. Similar to this also, like tick else if. So basically it is very similar to conditional statements like if else if. So all this. Okay, you already know the conditional statements. Similarly, similar to that of conditional statements only, you will be using this compiler directives like tick if def, tick if and def, tick else if and tick else. Okay, now coming to time scale. Okay, while you are coding and while executing the code or running the code in the EDA playground or in any simulator, okay, you will be observing at the side window, you will be observing the time scale units. Okay, like 1 nanosecond by 1 picosecond. So basically it is nothing but, okay, how where you will be generating the clock, right? So while you are generating the clock and while the simulator is being running, so at what period, like how your simulator is being run. Okay, so basically that is given by, like, Verilog simulation depends on how time is defined, because the simulator needs to know at what time the simulation needs to, like when you are giving the delay, okay, it should know at how it should use the delay, like it should be using it in the format of 1 nanosecond by 1 picosecond and 10 microseconds by 100 nanoseconds. So in order to know this, you should be using this tick time scale format. Okay, you should know about this tick time scale compiler directive. So basically when it comes to the tick time scale units, it is time unit by time precision. Okay, time unit is nothing but it is the measurement of delays and simulation time. Okay, in order to measure the delays and simulation time, you will be using this time unit. Time precision is nothing but how delay values are rounded off. Like when you are giving the precision time, it will be rounding off your delays. Okay, so I have already made the separate video of that tick time scale directives. Okay, you can check that video, right? So that is about the tick time scale. Basically, tick time scale compiler directive is in order to make you understand how the delays are being taken, how the simulator is being run. Okay, so basically this is about the tick time scale. So see, this is the example. Okay, if you are giving basically 1 nanosecond by 1 nanosecond, and when you are being rounded off, like if you are giving 0.45 as the delay, okay, based on this time scale properties, like based on the units of this time scale that you are being giving only, This particular values will be rounded off to the values like 0, 0, 1, 2. So this value is rounded off to 1, this value is rounded off to, okay, 2, and this is rounded off to 0. So basically this is how the round value will be taking place. Okay, so this is about time scale. And apart from this time scales, okay, you are having some time functions in order to know the simulation time. Okay, we have already discussed it in the previous, like we are when we are discussing about data types, we have already discussed it, like dollar time and dollar real time. In order to know the simulation time of the particular, at what particular simulation time your statement is being simulated, so basically you will be using this particular time function called dollar time. And in order to know the floating value, like in order to know the points value of the time, you will be using this real time. Okay, so these are the basic time functions in the Verilog. Now coming to randomization function. So randomization, so you will be using mostly about this randomization, you will be learning mostly about this randomization when you are learning about system Verilog concepts. But Verilog also can provide the random values, okay, but not as efficient as you are seeing it in system Verilog. So in order to provide the random values in Verilog, you will be using these three commands like $random. It will be generating, it is used to generate a random bits of 32-bit signed number, and you want to generate the 32-bit unsigned number, then you will be using the $u random keyword. Okay, and when you want to generate the values, like when you want to generate the values between 1 to 100, that means you are giving the range. And now what happens, within these 1 to 100 values only it will generate the random values. So when you are giving it within the range, then you will be going for u random range. Okay, clear? So these are some of the basic randomization functions in Verilog. Now coming to some system tasks and functions. Okay, so these are the basic system tasks or system functions, whatever you call it, whether task or system functions. Basically, in order to display the values, you will be using these four tasks: dollar display, dollar monitor, dollar strobe, and dollar write. Okay, so you will be seeing these differences. I have made a full length video on all the system tasks in detail. You can go there and check it out. So when you are using these tasks, you will be using the dollar symbol before. So these are called as system tasks. Okay, dollar display. So basically they are used just like in C you are having the printf in order to print values. Okay, in order to print values on the log file, you will be using four kinds, but in C you will be having only printf, but in Verilog you are having four kinds. So every kind have its unique features like dollar display, dollar monitor, dollar strobe, and dollar write. Okay, and here basically they have some unique features. You will be seeing them in the full length video. If you want to check that out, you can check it. So basically dollar display, it is used to display immediately. Okay, so in Verilog you are having like four regions. So every of these four tasks will be activated in four different regions. Okay, you will be seeing that in the next slide. Basically, so Verilog is having four regions. What are those? Active, inactive, non-blocking, and postponed or monitored region. Both we can call it as, mostly we'll call it as postponed region. Okay, so active region, inactive region, non-blocking assignment, monitor. So whatever code that you are writing in your RTL and in your test bench, mostly in Verilog. Okay, when you are using Verilog in order to write your code, every part of your code will be executed only in these four regions. Either it may be activated in active region or inactive region or non-blocking assignment or postponed region. But every statement or every logic that you are writing within your code will be activated only among these four regions. Okay, but in system Verilog, if you see, you are having 11 such regions in order to execute your code. Okay, that is advantage in system Verilog, because mostly we'll be designing for complex circuits. We need more regions when it comes to executing that particular code. Okay, that is why mostly we prefer system Verilog for verification than compared to that of Verilog. That is one important thing you should consider. Okay, but as for Verilog, you are having four regions. Okay, now talking about these four regions, firstly active region. Active region means basically which is used to like display the current events. Basically, as I told you, every code, like if your code consists of some display statements or some monitor statements or some data flow modeling logic, some behavior level modeling. Again, in data flow you are having some assign statements. Again, in procedural you will be having some blocking statements, non-blocking statements. Is it or not? So your code consists of all these things. So when you consider all these things, every part of your code, like blocking statement will be executed in one part of region, non-blocking statements will be executed in another part of region, all the display statements will be executed in one part, all the monitor statements will be executed in one path. So at which point are these being executed? Let us see. Now if you see, in case of region, active region, what are the things that will be activated? All the gate level modeling Verilog primitives, like Verilog, whatever you will be writing gate level modeling code, everything will be activated, evaluated in active region. Similarly, all the right hand side of non-blocking statements, like if you see the non-blocking statement, it is like this. Is it or not? So everything that is written inside expression of RHS will be evaluated in active region itself. And also when you are taking any assigned statements, continuous assignments of all modules, similarly blocking assignments, similarly dollar display, dollar finish commands, so all these will be executed and evaluated in case of active region itself. So when it comes to evaluation, all the gate primitives and all the RHS of this particular things, like all the RHS of non-blocking assignments will be done in case of active region. Similarly, when it comes to execution, when you are not using a non-blocking statement, when you are using a blocking statement, then the working, like execution of RHS and assignment of LHS is also done in the active region. And also when it comes to system task, dollar finish and dollar display will be executed in this particular active region. Clear? Now coming to inactive region. So basically, when you don't give any delay and when you are giving hash zero delay, okay, there is some difference between this. Actually, without giving any delay and hash zero delay are both same. But when it comes to execution, if you are not giving any delay, that will be executed in active region. If you are giving a hash zero, then statement is executed in the inactive region. Okay, so that is the main difference. Because when you are writing some code in system verilog, basically in the previous sessions when we are discussing in system verilog, I have given you some questions. So in my LinkedIn, you can go follow in my LinkedIn ID. There I have given some questions on fork and join. Okay, where I have given some codes like hash zero. Okay, I have given some statement like dollar display with hash zero and dollar display without hash zero. So when you go there and check it out, you will go, when you go there and execute, you will know the difference between hash zero and without giving any zero. Okay, so basically when you are giving hash zero, because this is the most frequently asked interview questions, like many questions will when any interviewer want to trick you, they will be giving such questions like what is the difference between without dollar display and hash zero dollar display. So what will be the difference? Actually, this is executed in active region, this is executed in inactive region. Okay, there may be no or not much difference, but this is the major difference. Okay, like they will be executed in active and this will be executed in inactive region. Right, so this is the about inactive region. Now coming to non-blocking assignment region. NBA means non-blocking assignment. You will know from the name itself, you could know that whatever you are assigning, okay, like non-blocking assignments assignment, like if you see non-blocking assignments, LHS is equal to RHS, is it or not? So this is evaluated in active region. Now the assignments takes place in the non-blocking assignment region. Okay, that means the assignment from RHS to LHS is taken at non-blocking region. Now coming to postpone region. So the system task like dollar monitor on dollar stop will be activated in this, executed in this particular postpone region, right? So this is about the regions in Verilog, right? Clear? So along with this, you are having some system controlling system tasks, like these are basic system tasks, okay, in order to display the thing. And when you want to control the simulation, you will be using some similar tasks like $stop, $finish, $reset. Okay, $finish means in order to terminate the simulation. Okay, $stop means in order to suspend the simulation. That means even though there is code, if you are using $stop, it won't run the remaining simulation and it will be getting out of the particular thing. And $finish means it will be after completing all the execution, it will be terminating the simulation by itself. $reset, okay, in order to reset the simulation back to zero time. Okay,